everyone, welcome back to Dr. Expert. Today we continue to use the class tense. Now let's start. Click opens. The class tense, click on tense. You can use tense or tense forward. We start everything from the setting, how to define unit, how to define design code or zone, and everything you can start from here. Yes. It's either local. You select the USA, the design code is based on the USA. The SI code and Aisc for the steel, for concrete, and United Kingdom for the BS, Eurocode, Europe, and the design code is based on the Eurocode, Canada, Australia, and Asia. And now let's click close. I will start from here. Okay, click on option. In option, the original setting in the USA. Okay, click on the USA. United States, the default calculation setting, and the unit based on the unit. You can choose on the US unit. US unit. The length is feet, mass, slug, pound, keep. This is the imperial unit. If you change from the imperial to SI unit, the standard international unit, the length is meter, mass kilogram, and force kilonewton, moment kilonewton meter. This is the SI unit. So it's depend on your project and your location. If you based on the US, you can use the imperial unit. If you are outside the US, you can change to SI unit. It's easy to understand about the unit system. Now let me change to the US unit. Okay. And the local, we select the USA. Click on new. In the new, you can click on the 10 calculation USA SI unit or US unit. Now let me change to the SI unit and start to design steel and steel beam. Okay. Now let me click on the steel beam. Okay, geometry. The unit is the imperial unit. The length is foot, and the section is a square inch, and energy inch power 4. So when you want to change the unit, you have to change in the option. Okay, when you change in the, now let me click OK. Come back and click on the new. When you click on new, and you can change the unit. Okay, you can change the unit as US to SI or from the SI to US, but the unit actually it doesn't work. So before you can change this unit, you have to, now let me close, click on the option, change it first in the option, change from the US, come back to the SI unit. Okay, and click on new, click on the SI. Now let me come back, click on steel, click on steel beam ACI by 360, click calculate. Okay, this is the SI unit, the length in a millimeter. Now let me click on the geometry. You see here the red letter geometry and combination. You have to click and define it before you continue to Aisc design. And for the loading, it is the default loading, so you can also edit to add more load. Now let me start from the geometry. Now let me change to 6000, and the restraint we keep it in default. In the loading, you can add the default load, either the load. Now let me change it to the 7. Yes, correct. Add new load, and the load change to the unit to 5 kilonewton per meter. Add the one is the light load, and the minuscule load is 5 kilonewton per meter length. Click OK. The combination one, the load 1.2 and light load 1.6. This is the partial sensitivity factor for the load and light load. Click OK. And for the design option, we design based on the Aisc 360 version 10. Now click on design option to change the version. Now let me select the later version and the design based on the L or SD. You can also change to ASD. Okay. Now let me select for the L or SD. And the US unit. Here USA, we keep the SI unit. In the cross section scale option, the limit deflection, you can define the limit deflection. The design axis, we design for the measure or for the mirror. Now let me keep for the measure axis. And for other additional load not apply. The torus null buckling factor calculated. Click OK. Now we let's compare with the Eurocode. Okay, compare with the Eurocode 3. Click on the section. You see here now the section based on the Aisc 15th edition. How you can select other section? This is the default section for the Aisc. Now I want to change to the China section, or I want to use the UK section, or I want to use the European section. How can we change it? Now click on the console again, and steel grade. You can see here the steel grade is also A992 A588 is the steel grade of the USA. Now I want to change it to the Eurocode. How we can change the steel grade? Okay. Now let me start again. Click on design option, cross section sketch. Okay, this is the sketch of the section. The select design from. Now let me change to the Europe. So the section, yeah, the tab by section we will do on the Europe. Okay, click OK. Beam detail, you can click on the section again. You see here, this you can change it and click on the section IPE 120 AA, or you can select one one section IPE 360, or you can do a wide plane or hollow circular section or 3 sections. Now let me click on the IPE 240. We compare with the Eurocode. I has another tutorial about design steel beam in the Eurocode, simple supported beam and fit supported beam. By using the IPE 240, it easy to compare each other when we design the same issue load and descent span, and the section property is the same. Now let me select the section property IPE 240, click select, and the year you can click the minimum year 250. But in the Eurocode, the minimum year strength for steel in the standards is 235. Now let me change it directly. Okay, you can try it 235 enter, and the tensile strength you can again. Now let me click on the right click calculate. And let me change to 400. Yes, the correct yield strength and tensile strength. And the design code is Aisc 360 version 16. The correct. You see now the bending moment is 0.833. And the shear strength is 0.205 and the deflection is 1.34. Now let me check the intermediate lateral pressing. The default setting is keep the beam is fully restrained, but actually our beam is not fully restrained. We have only the restraint at the end of the beam. The support, we design it as the pin support, so we can call it simple supportive beam. You see, with the redistributed load and light load. Now let me check the option we want to change to the none. So what does it mean when we click change to the none? This means the compression flange can be moved laterally when the load applied and the top flange, and it also rotates about its own axis. So the phenomena we call it LTB, lateral torsional buckling. In the presence of lateral torsional buckling, the capacity of the section will be the issue. Now let me check for the case the full, when we assume it a fully restrained about the buckling, about the lateral torsional buckling. The design is based on the section design for the flexural and for the shear, not include for the LTB. Now let note this bending moment about the measure axis. The measure axis in the USA code is the 88. The measure axis in the Eurocode is the YY. And the capacity, this one is the apply. Yes, the apply. When you apply distributed load, and the result of the moment is 64.6, and this one is the capacity of the section to receive for the flexural. And for the shear, so the ratio is 0.205, and for the flexural the capacity is 0.833, and the against deflection is over 1.34, is over 1, it's not acceptable. Yes, now let me change it, or you can now let's check the option for. Okay, click on the finish. Now let's check steel beam analysis design Aisc 360 version 16. We designed based on the LOSD methods. The result moment is 64.6, and the maximum shear is 33.1. The section IPE 240, user defined, and the minimum design, the minimum yield strength of steel beam is 235 correct. The tensile stresses is correct. Yes, modulus elasticity is either partial safety factor. And classification of the friction for the local backlink. Okay, the compact. For the Aisc, you can classify compact or non-compact or slender. The classification of the flame and the web, all of those classification are in compact. Design for the shear. Now let's check for the shear. The apply is 43.1 and the nominal shear strength is 209.8 kilonewton. The final design shear strength is equal to 209.8 kilonewton. The design moment for the fixture. Yes, this is the applied moment is 64.6 and the design fixture strength is 75.5 kilonewton meter. So this beam can resist, yes, can resist the applied moment, yeah, 64.6. For the plastic is 86.2, and when we apply with the safety factor is equal to 37.5. It's greater than 64.6. So the beam is pass design flexural strength. It require flexural strength. For the deflection where now let me check with the Eurocode. Okay, I only compare with my Aisc. Let's click and open my Aisc. We try to compare each other. What is the difference between those two codes? Now let me check on the section. In the section you can change it right to the database. Now this is the database sheet. I can change it directly to has a HEA A100CT as I want. Now let me click and change it right here. Yes, all the data will be automatically updated. Now let me check it back. IPE IPE 240. Okay, and apply moment. Now we keep it the same. Now let me check. 64.6. Okay, 64.6. And shear force 63.1. Then the class is class 1. The yield strength is 235, and apply the strength, yeah, pin with distributed load. Destabilizing load. We should classify destabilizing or stabilizing load because our beam is unrestrained beam. We has only the support condition, pin, the compression plane freely rotate to sideways and also rotate about its own axis. In the case, we should design as the stabilizing load and load applied at the top. Now let me compare with the latence. What is different? And now let me check. I change it to the stabilizing load and load apply at the scene center. Okay, now everything is fine. Let me check. Okay, let me check for the C capacity is 259.74. Okay, let's check compare with the duct latence. Yeah, this is for the shear. Okay, for the shear is 209.8. So based on the Eurocode, the shear strength, design shear strength is higher than Aisc. Now let me check for the NYLD for the plastic. Yeah, for the plastic, let me check. This one for the plastic, the result is 86.2. Now let's compare. Yes, 86.2 is the same. CYOD is equal to section modulus at the plastic. Yeah, WPLY multiplied with the SY and divide by the partial fatigue factor. So for the code is the same. We apply the SY. FY is equal to 235 multiplied with section modulus at the plastic is equal to yes, it's the same. So the final result is equal to the same, 86.2. For the code is the same. And design physical strength is equal to 37.5. Okay, so it is the final for the Eurocode, but for the Aisc we had to multiply with VB, so it is due to 75.5 kilonewton. In the Eurocode, the gamma is equal to 1, so when you divide by 1 it is equal to 86.2. But in the Aisc, VB, you can check the VB. Yeah, VB is equal to 0.9. Okay, 0.9. So the final design physical strength is equal to 77.5 kilonewton met. The design for the physical, okay, design capacity for the physical. Okay, now let's compare. In this stage, everything is the same. Okay, it's the same. It's the same. We do not verify with the LTB. Okay, we design in the state as the beam is the restraint beam. Okay, it's the restraint beam. So when the beam is designed for the unrestrained beam, we have to change the parameter. Now let's come back. Let's come back and we change the intermediate lateral pressing to none again. And the ratio now is 1.461. Click on finish. Okay, now let me check. Let me check. Everything is the same. We just change from the restraint beam to unrestrained beam. So so we are automatically calculate the yes for the shear, flexural, and for the lateral torsional buckling. Yes, this is the LB limited and breath length is equal to 1382 millimeter. So when you apply the pressing, the intermediate pressing, you should apply it within this length. You can apply to 1200 millimeter or less than 3082. Now let me set to 1100 millimeter. You should apply it below than the limiting unbreak length to prevent lateral torsional buckling occur in the beam. Distance between plane centroids. Yes. Limit unbreak length. This is the moment at the 1/4 of the beam segment MA, MB, MC, and MABS. We had to calculate the CB, lateral torsional buckling modification factor. In the Eurocode, this factor is C1. In Eurocode, we calculate C1, C2, C3 according to the load condition. Yes, stabilizing or non-stabilizing or destabilizing load applied at the C-center or on the top plane or on the bottom plane. Now we have to check it. The value of the CB is equal to 1.136. Now let's check in the Eurocode. It's equal to 1.132. Now here is 1.136. Yes, 1.132. Okay. The critical frictional stress and the nominal frictional strength for the lateral torsional buckling is equal to 49.1. 49.1. This is the MCO. Yes, the MCO. Now let me check. Yeah, in the Eurocode, the result is 51.3. Yes, for the Aisc is 49.1. The design frictional strength is equal to 44.2. Now let me check. This is we can compare with the MBOD. MBOD for the Eurocode can design based on the method I or H section or with the general approach. The general approach, the result is higher than equivalent value section. So here the result is 46. And for the Aisc is 44.2. Yes, 44.2 for the MBOD. After we include for the lateral torsional buckling. And for the general approach is 40.7, is lower than the Aisc. Okay, now let's verify. So now let me change the condition of loading. Here we check the condition is similar, but what is different right now is the load condition. Because our beam designed to resist as the understrain beam to resist the load directly by this beam without internal or intermediate restraint. So we had to change the load condition from the stabilizing to destabilizing, and load applied at the top plane of the beam. Now let me check again. The MBO now reduced to the 34.7, and for the general for the equivalent section now reduced to 39.7. You see here the design in the software, the latence according to the Aisc 360 version 16 do not have option to change the load condition, stabilizing or destabilizing. Now you see no option to change. Now I think that this software calculate in the condition of load stabilizing. Okay, on load stabilizing, not include the distance from the C center to the applied load. Okay, not include the distance. So when you include the distance in the Eurocode is ZC. So the section will be reduce the capacity when you consider it from the shear center to the applied load at the top plane. You see here the result of the final MBOD to receive for the lateral torsional backlink now reduced to 39.7. Yes. Now let me come back. In the class 10, no option to change the condition, stabilizing or destabilizing. Let me click OK again. This is my assumption. I think that the class 10 is not designed for the destabilizing load. It designed stabilizing load, not include the distance from the C center to apply load position. Okay, you can check the design. So be careful when you use this software. You should verify it again and again to check what is different and how you can control the software. This is my personal opinion. You can recommend and comment in my channel. I will correct it. I explain everything here. Has something wrong, you can correct me. Okay. Let's click finish. Okay. This is how we can compare each other. This is for the design physical strength as the take into account the LTB, and this one is the lateral torsional backlink modification factor. It's similar with the C1 in the Eurocode 3. Okay, 1.132, and the critical physical stress in the Eurocode designed for the elastic critical moment, not critical physical stress. Yes, this one for the moment. You can change and convert it to stress and compare each other. Now in the case it's different. We can compare. In this unit is the kilonewton meter, and for the critical physical stress in the class 10 is in megapascal. So finally you can compare with the design physical strength. Okay, the nominal physical strength for the lateral torsional buckling. This value. Okay, now let's change. Let's compare. Yes, this value. So what is different? The condition of loading, stabilizing, and load apply out the C center. Again, at the C center. Okay, you see now. Okay, this one. This friend we call her the Aisc, include the safety factor 0.9 multiplied with the Mn, so it's equal to 44.2 kilonewton meter. Thank you for your watching. I hope you enjoy with this tutorial. The class 10 is a powerful software, but we have to check, and we should know what is different when you use this software and how to control it. I hope you enjoyed the tutorial. Sorry. Thank you.